Okay, we're going to come back to this problem here. Now, go to example 1. It says a bank account contains $5,000. It earns 3% interest each year. Now, it's interest, but not compound interest. Compounded means it's multiple times in a year. How many years will it take the account to reach $6,000? So, you're going dollars in years. Years is X, times always X, dollars is Y. So dollars per year. Remember, the time unit is your X. So dollars per year is 3%. So there is no dollars per year. It's a percent per year. So that means it's not going to be a linear function. It's going to be an exponent function. Okay, expo. If you have an exponent function, you have to know what your factor is. It might be growth, it might be decay. Read the problem. Well, 3% interest means it grows from its original amount. So we're going to take 100% and add 3%. So that's 103%. Move the decimal back twice, and that's going to be 1.03. Now I'm going to make a table on this problem, okay, just on this one. So dollars is Y, years is X. So 0, 1, 2. So the dollars start at 5,000. Then you start multiplying instead of adding by your exponent factor, 1.03. Okay, 5,150 after the first year times 1.03, 5,304.50 after the second year, and then that keeps going. Now I need to find when this is going to get to $6,000. That's a question here. Okay. Now you're not going to see me do that table anymore. Okay. You're going to go right to this equation here on an exponent function. It's called a times b to the x power equals y. Okay. All right, now you need to know, I didn't do a great job on 7.1 of explaining this here. Okay. I would write what a, b, x, and y represent. Now here's the thing. The a and the y are the same unit. Okay. So look up here. Y is dollars. So dollars here, that's where the money ends at. A is dollars, that's where the money begins at. Okay. A and Y are the same unit. Okay. This is the beginning, this is the end. Okay, so the money beginning, we began with 5,000. Now the B is your exponent factor, which is 1.03. Okay. And then X, well, look in your legend, it says X is years. How many years you got in this problem? You keep looking back here. I don't know, so you put a question mark. That's because that's what we're figuring out. And the Y is where the money ended at, which is $6,000. Okay, now you just plug the numbers into the equation and decide what to do next. So you have 5,000 for A. Your B is the 1.03. Remember, the X was the unknown. And the Y is your money that you ended with, which is $6,000. Okay. Now you need to solve for the remaining variable. So you're solving for X. Here's the deal though, X is a power. So what did I tell you to do if X is a power? Well, parenthesize it's the power along with the base. Okay. Now you're going to use this. First thing you do is get rid of the operation outside. So you need to first divide by 5,000. Not minus it, it's times, so you divide by 5,000. And that's 1.2. Then you use your COB, okay? Change of base, COB, change of base. That's when you take that exponent and set it equal to the log divided by log. So remember that 1.3 is on 0.3 is on bottom, 1.2 is on top. You got to get that right, okay? The base has to go on bottom. So I take the log of 1.2 divided by the log of 1.03, and round to the nearest hundred, it'd be 6.17, okay? Now, if you want to verify if that's correct, you can take your 5,000 times the 1.03 power, just put 6.17, and it should be about 6,000. It's not going to be exact, but it's darn close because I had to round it. Okay, example 2. In the year 2000, the average price of a football ticket was $50. Tickets are increasing by an average of 6% per year. How many years does it take the price of a ticket to reach $75? So again, you have dollars and years. I'm not going to waste time with that table now. So per dollars per year. On expo functions, I don't normally make a table. I showed you how it would work, but okay, the percent per year is 6. So it's an exponent function, and I need to identify what the factor is, whether it's, so I take 100%, and I'm going to be adding 6 because it says it's increasing. Please read the problem. So the exponent factor is 1.06, okay? Now, you know it's an exponent function. You might as well just line up the a times b to the x power equals y. So you got to know what your a, your b, your x, and your y represent. Now, over the a, over the y, look at what the y is. Y is dollars. So put a money sign above y, a money sign above a. A is where the money began at, which is 50, okay? The y is where the money ended at, which we know that's 75. Then the b is the 1.06 growth factor. And the x, what we're finding, no, 2000, that's a year, actual year. It's not how many years, so you put question mark. You don't know this, so now you set it up. So you have 50 times 1.06. Remember, we don't have the x. And the y is 75. Now you're solving for x. X is in a power. You see that with the caret symbol. Okay, so parenthesize the power along with the base. Okay, outside you have a times 50. You need to divide by 50 before you determine your next step. You are going to use COB, but you have to eliminate the operation on the outside. That's 1.5, change of base. So COB, change of base. So that exponent equals log 1.06 must be placed on the bottom, 1.5 must be placed over it. So you take the log of 1.5 divided by the log of 1.06, round to the nearest hundredth, 6.96. Now, I don't really care how it's rounded. You're going to see me just rounding it to the nearest hundredth. So years is approximately 6.96. So if I take the original amount 50, multiply it by the factor, and raise that factor to the power of 6.96, it should come out darn close to 75, which it does. Okay, so I know I did it right. Okay, a new car is purchased for $16,000. The car declines in value by 10% each year. Find how many years it takes the car to get down to a value of $5,000. So you got dollars and years. So per dollars per year. Dollars per year is 10%, okay? So it's a percent per year, so you know that that's an expo. You have to know the factor. This time it's not going to be a growth factor, though. It is going to be a decay factor because it's declining, so it's minus 10%. The way you do the problem is the same. You just subtract the 10 instead of adding it. You move the decimal twice, and it'd be 0.90. Okay. So I'm still going with a times b to the x power equals y. So I got to know what a is, what b is, what x is, what y is. Remember, A and Y, look at what the Y label is. It's a dollars, so dollars, and dollars is also the A, okay? The A is the dollars you began with, which is 16,000. You see that in the problem. The Y is the dollars you end with. Again, A is the beginning, and the Y money is where we ended, okay? And we ended at 5,000. Makes sense because it's decaying. Now the B is 0.90. And X is what we don't know because X is years. That's what we're figuring out. Okay, so A, you got 16,000 times 0.90. X is what you don't know. Y, we have 5,000. Okay. Now you're solving for the X. X is a power. So I need to see that. You need to divide by the 16,000. So yes, I'm going to divide 5,000 by 16,000. 0.3125. Now it's time for the COB. Okay. So I take that exponent from in there, and I know that that equals the log of the product divided by the log of the base. Okay, 11.04. And if you want to check that answer, you can take your original amount, 16,000, multiply it by your exponent factor, and raise it to the power of 11.04. And it should come down darn close to 5. Yeah, it's close enough to 5,000. Okay, I'm going to go back to the first page here. You have $1 in a bank account. It doubles in value each month. How many months does it take to have it be worth $1,000? Yes, you can get there. It goes quicker than you think, actually. Dollars in months. X is months, Y is dollars. So the dollars per month. Again, it's a percent, but well, not a percent. Instead, it doubles. Okay, that's what it does. So it's an expo. You do have a factor, and the factor on a double is just 2 whole. You don't do 100, you don't do anything. Okay. So A times B to the X power equals Y. Okay. Remember, A and Y have the same label. Y is money, so you got money here, money here. A is where the money began, $1. Y is where the money ended, of 1,000. The B is 2. And the X is what we don't know. Okay. So A, you're going to take 1 times 2 to the X power equals 1,000. X equals, okay. Again, X is a power. Now, nice thing here, you have a times 1. Now, if you have a times 1, you can really just delete it because dividing by 1 would just keep that at 1,000, so it could really just be deleted. And I can take the X and do the COB with it, change of base. So 2, 1,000. So we take log 1,000. Divided by the log of 2. And yeah, it didn't take as long as we thought. 9.97. Okay. And the answer is months. Sorry, I didn't put that. Now let's prove why that's right. Because if I take the $1 I had original and times it by 2 and raise the 2 to the 9.97 power, look at that. Pretty darn close to 1,000.